Okay, here are solutions for quiz 8 for Math 251. We're given this function, f of x equals x minus 12 times the cubed root of x. Alright, and asked all sorts of stuff. Asked to find its critical values, asked to classify those critical values, asked to determine the intervals on which this function is increasing, decreasing, concave up, concave down. I guess that's it. So okay, let's do it. Find all critical values of this function. You need to know that critical values come in kind of two flavors. They either happen when f prime of x equals 0 or when f prime of x is undefined. Okay. So either way, we'll need to know what the derivative is, what f prime of x is, so maybe we should figure that out first. Switch colors here. So let's figure out f prime of x up here. Well, fortunately, it's not too hard to figure out what that is. It might help to first rewrite your function. Instead of x minus 12 times the cubed root of x, you could say it's x minus 12 times x to the 1/3 power. And then it's a little bit easier to see that the derivative is 12 times 1/3, which is 4, x to the negative 2/3 power, which, if you prefer, you could rewrite as this. Maybe I should talk through that a little bit. X to the negative 2/3 power is the same as 1 over x to the 2/3 power, which is why it's down here in the denominator. And x to the 2/3 power is the cubed root of x squared. So anyways, here's the derivative, this mess right here. I want to figure out when this mess equals 0 and when this mess is undefined. So let's do it. Which one do you want to do first? It doesn't really matter. Undefined's a little bit easier. For undefined, there's 3 rules. Can't take the log. Well, there's at least 3. Can't take the log of a number that's not positive. Don't care about that. There's no logs going on. Can't take the square root of a negative number. You might worry about that, but actually since it's cubed root, we don't have to worry about that. So really only the rule that we have to be careful of is we have to make sure we don't divide by 0. We'll divide by 0 if this thing down in the denominator, the cubed root of x squared, equals 0. So if I cube both sides of the equation, we get x squared equals 0. And if I take the square root of both sides, I get x equals plus or minus 0, which is just 0. In other words, I have a critical value at x equals 0. Do I have any other critical values? Well, let's see. We can figure it out by figuring out when our derivative, 1 minus 4 divided by cubed root of x squared, equals 0, our other type of critical value. How do you solve this equation? You have a couple options on what you can do. I'd probably add this term to this side. So I got 1 equals 4 over the cubed root of x squared. And then multiply both sides of the equation by the cubed root of x squared. Got to be a little bit careful there. I'll explain what I'm talking about once I finish writing it. But what I did is I multiplied both sides of the equation by the denominator here. So it appears up top here and it cancels out on this side. You can only do that. You have to be careful. You don't want to multiply both sides of the equation by 0. You'll lose all your information. Fortunately, we don't have to worry about that because the only way we'd be multiplying both sides by 0 is if this thing were 0. We've already taken care of that case over here. So now I have an equation we need to solve. The cubed root of x squared equals 4. Well, a couple different ways you can do this. You could cube both sides of the equation and get x squared equals 64. Maybe that's easiest. I don't know. Numbers get a little bit big. And then take the square root of both sides of the equation and then get x is plus or minus 8. Be one way to do it. Another way is to recognize that this is really x to the 2/3 power. So raise 4 to the 3/2 power. 4 to the 3/2. Well, the half, the 2 in the denominator is the square root. Just take the square root of 4 and then cube that thing. And be careful when you take the square root, put in the plus or minus. Anyways, either way, you'll get plus or minus 8 for your answers. What I'm saying is we got 3 critical values. 0, 8, and negative 8. Okay, now it wants me to classify one of my critical values, this one over here, using the first derivative test. It's important that it tells me to use the first derivative test because you can only use the second derivative test on this type of critical value. I couldn't use the second derivative test on this type. But anyways, first derivative test. The way you do that is, well, you're going to look at the first derivative. Nothing too surprising there. We already figured out that our first derivative, f prime of x, is equal to, I'll pick your favorite of these forms. Maybe I'll use this one. 1 minus, I'm going to use the top one. 1 minus 4x to the negative 2/3 power. So here's my derivative. There's only 3 spots where this derivative can change sign at 0, 8, and negative 8. So if I set up this little number line here, got negative 8 way over here, 0 here, and positive 8 here. And really it's only this value that I'm testing. So what I want to figure out is when I'm a little bit to the left here, pick whatever your favorite number is, somewhere over here, and then a little bit to the right of this point, is the derivative negative or positive? That might have made it more confusing writing it that way. How about this? I got 4 regions. Right, these 3 critical values divide my number line up into 4 regions. 1, 2, let's label them. 1, 2, 3, and 4. If I were using the first derivative test to classify all of these derivatives, I'd want to figure out the sign of the first derivative in each of these 4 regions. Since I'm only using it to test this one, I really only care about region 2 and region 3. So let's test region 2. To test region 2, you pick any number from region 2, so any number between 0 and negative 8. Your choice. You can choose a fraction if you want. You choose anything you want as long as it's less than 0 and more than negative 8. I'll choose negative 1 because that seems like that might be easy. And so what I want to do is figure out what is f prime of negative 1. Well, f prime of negative 1 is 1 minus 4 times negative 1 to the negative 2/3 power. Negative 1 to the negative 2/3 power is the same as negative 1 over negative 1 to the 2/3 power, which is equal to, well, let's see, negative 1 squared is positive 1, and the cubed root of positive 1 is positive 1. So 4 divided by positive 1 is 4. 1 minus 4 is negative 3. Really, I don't care that it's negative 3, I just care that it's negative. What I'm saying is that in this region, my first derivative is negative. What about in region 3? Again, choose any number you want, as long as it's greater than 0 and less than 8. I'm going to choose positive 1 because that seems easy, and figure out f prime of positive 1. So that'll be 1 minus 4, 1 to the 2/3 power, negative 2/3 power. It's hard to read. Let me rewrite that. 1 has this nice property that you can raise it up to any power that you want and just get 1. So this is just 1 minus 4 times 1. In other words, it's negative 3. Same answer I got up here, huh? What that tells me is that my first derivative is negative here. So, by first derivative test, x equals 0 is neither a local min or maybe nor max. How do I know that? Because the first derivative is negative, so my function is decreasing when I'm to the left of this point, and it's still decreasing when I'm to the right of this point. So it couldn't possibly be a minimum. It was going down and then it goes down further. Can't possibly be a maximum because it's going down and going down further. It's neither. So there's my answer. Okay, now we got to do that 2 more times, except now it wants me to use the second derivative test. I kind of like the second derivative test better, to tell you the truth. So for the second derivative test, no big surprise, we're going to have to figure out what the second derivative was. The first derivative was 1 minus 4x to the negative 2/3 power. That look right? Yup. So the second derivative, let's see, the derivative of 1 is just 0. Using the power rule here, I would get, how about I write it out? It's the derivative of 1 minus 4x to the negative 2/3, which is the derivative of 1 minus the derivative of 4x to the negative 2/3, which is 0 minus 4 times the derivative of x to the negative 2/3, which is negative 4 times negative 2/3 x to the negative 5/3. In other words, it is positive 8/3 x to the negative 5/3. Or if you prefer, it's 8 over 3x to the 5/3 power. Anyways, this is my second derivative right here. So if I want to classify my remaining critical values, what I need to figure out is what is f double prime of negative 8 and what is f double prime of positive 8. Well, let's see, f double prime of x is this thing, so f double prime of negative 8 would be 8 divided by 3 times negative 8 to the 5/3 power. Now that looks like a mess. I don't want to figure out what that is. You don't have to. I mean, you can if you want, but you don't have to. Negative 8 to the 5/3 power is going to be a negative number. A positive number divided by a negative number is a negative number. This thing right here is less than 0. That's all that matters. Over here, it's going to be 8 divided by 3 times 8 to the 5/3. Well, let's see, 8 to the 5/3 power is a positive number. A positive over a positive is a positive. This thing is greater than 0. I don't care what it's equal to, just that it's greater than 0. The second derivative test tells me that when the first derivative is 0 and the second derivative is less than 0, and my graph looks, roughly speaking, like this. I have a local max. Right, this is concave down, second derivative is less than 0, but it's flat at that point. Over here I have a local min. Why do I have a local min? Because my second derivative is positive, meaning it's concave up. So roughly speaking, it looks like this. So a local max at negative 8, local min at 8. If you want to talk more about those, it's a max at negative 8. That makes sense up here because if we had tested this region, we would have gotten a positive number. So the first derivative is switching from positive to negative. It was kind of at the top of the hill. It used to be increasing, now it's decreasing. We have a max here at negative 8. However, at positive 8, we used to be decreasing, but if you test a number from region 4, what you'll find is the first derivative is positive, so it went from decreasing to increasing. We have a minimum. But we didn't figure those out using the first derivative test. We figured them out using the second derivative test. Okay, finally, determine the intervals on which f is increasing, decreasing, concave up, and concave down. We already have most of those. Increasing. Well, using the answers that I have so far, I knew it was increasing when I was to the left of negative 8. And then it's decreasing all throughout here. And then it's increasing when I'm to the right of positive 8. In other words, it's increasing from negative infinity up to negative 8. And then again from positive 8 up to infinity. And if that's where it's increasing, I can figure out where it's decreasing. Well, it's decreasing from negative 8 all the way up to 0. Whoops. As we saw in here, It's decreasing on this interval, and it's decreasing on this interval from 0 to 8. So also 0 to 8. Why did I exclude 0? Because the derivative was undefined at 0. If you remember, we figured that out earlier. There's a critical value there. So it wasn't increasing or decreasing. What about concave up and concave down? Well, to figure out where it's concave up and concave down, I'm going to have to look at the second derivative. Fortunately for me, I already calculated the second derivative. I know that f double prime of x is equal to this mess. 8, let me write that a little bit better. 8 divided by 3x to the 5/3 power. So the only place where this thing switches concavity is when x equals 0. Right? The concavity is never equal to, the thing never equals 0, but it's undefined when x equals 0 because I'll divide by 0. So the only possible place where it can switch concavity is when x equals 0. So I just need to know when it's to the left of 0, is it concave up? And when it's to the right of 0, is it concave up or concave down? And the way I can figure that out is, well, I already figured out that at -8, it was concave down. So what that means is it's concave down everywhere from -infinity up to 0. Because the only spot where it can change is at 0. And I figured out it's down at -8, so it must be down for all of this. Concave up, by that same logic, from 0 to infinity, because the only spot it can change is at 0. And at +8, I already saw it was concave up, so it must be concave up all throughout here. There's that answer, and I guess that is the end of this quiz.